So have you ever wondered how these massive tech companies can push out new features, sometimes multiple times a day, without the whole system just collapsing? Well, the secret sauce is a philosophy, a culture, really, called DevOps. Today, we're going to pull back the curtain and demystify it. We're going to talk about how you can go from the absolute chaos of manual work to the calm control of an automated system, and we'll be looking at it through the lens of Google Cloud.
All right, so here's our roadmap. First, we're going to talk about why the old way of doing things is just fundamentally broken. Then, we'll build up from the ground, piece by piece. We'll start with automating our infrastructure, then build our CI/CD assembly line, and finally, we'll talk about why this whole journey is so worth it. Sound good? Let's dive in.
Okay, let's start at the beginning. To really get why we need all this automation, you first have to understand the pain, the real tangible pain of doing things by hand. Oh man. We've all been there, or at least heard the horror stories, right? It's 5 p.m. on a Friday. You take a deep breath, you push the button to deploy the new code, and boom, everything's on fire. The next 3 hours are just this frantic mess of logging into servers, trying to manually patch things, and praying you can fix it before your weekend is completely shot. That feeling, that stress, that risk, that's exactly what we're trying to get away from. This slide really just lays it all out, doesn't it? On the left, you've got the manual way. It's slow, it's super risky, and because a human is doing it, it's inconsistent. It's just begging for errors. But on the right, you have the automated way. It's fast, it's incredibly reliable, because a machine does the exact same thing every single time, and it's repeatable. Most importantly, it's auditable. You have a perfect log of everything that happened.
In this quote, this really gets to the heart of the DevOps mindset shift. You never ever log into a live server to make a quick fix. That's how you get these mystery configurations that nobody understands and that break everything 3 months later. No. The code is your single source of truth. If something goes wrong, you fix the code and you let your automated system, your pipeline, safely roll out the fix.
Okay, so how do we start building this beautiful, automated world? Well, you have to start at the bottom, with the foundation itself. And I'm talking about your actual infrastructure. Your virtual machines, your networks, your databases, the whole shebang.
So, let's introduce our first big concept, infrastructure as code, or IAC. The idea here is simple but revolutionary. Instead of clicking around in the Google Cloud console to create a virtual machine, you define everything in a text file. You literally write code that says, I need a network that looks like this, and 3 servers with these specs. That code becomes the absolute blueprint for your entire environment.
The best analogy, honestly, is building a house. The old way is like trying to build a house from memory. Every time you build it, it's a little bit different. Infrastructure as code, on the other hand, is like having a detailed architectural blueprint. Anybody on your team can take that blueprint and they can build an absolutely identical house perfectly every single time.
So why is this blueprint model so powerful? Well, first, it becomes that single source of truth we talked about. Any change to your infrastructure is now a change to the code, which means your whole team can review it. This totally gets rid of those weird, undocumented, mystery configurations, and it prevents those heart-stopping mistakes, like someone accidentally deleting the production database because they clicked the wrong button in the console.
Okay, so we've used infrastructure as code to create our blueprint. That's our foundation. Now, we need an automated factory that can actually build our application and put it onto that infrastructure. This is where the CI/CD assembly line comes into play.
You've probably heard this term, CI/CD, thrown around a lot. Let's break it down. The CI part is continuous integration. Think of this as an automated quality check. Every single time a developer saves their code, the system automatically builds it and runs tests to catch bugs right away. The CD is continuous deployment. If and only if all those tests pass, the system then automatically releases that new version to your users. No buttons, no manual steps.
I want you to picture a real factory assembly line. It starts when a developer commits their code. That single action kicks off our factory engine, which in Google Cloud is a tool called Cloud Build. Cloud Build grabs the code, compiles it, and packages it up neatly into a container. And here is the absolutely critical part for accountability. It slaps a tag on that container with the unique ID of the code commit. This gives you a perfect, unbreakable audit trail from the app running in production all the way back to the exact line of code that created it.
A great factory isn't just about moving fast. It's also about having world-class quality control. I mean, shipping broken code quickly doesn't help anyone. So let's talk about how we build testing and security right into our assembly line.
The key thing to understand here is that testing isn't just one big step at the end. It's a series of gates. First, in a development environment, you run integration tests to make sure all the different pieces of your app are talking to each other correctly. Then, in a staging environment, you run load tests to hammer the application with fake traffic to see if it can handle the pressure. And finally, once it's live in production, you run a quick smoke test. It's kind of like turning on a new TV. You're just making sure the screen turns on before you walk away.
But what about security? I mean, for a lot of companies, their source code is their crown jewels. You can't just have that build process happening out on the public internet. And that's exactly what a tool like VPC Private Pools is for. It basically creates a secure, isolated bubble for your assembly line to run inside of, completely cut off from the outside world, ensuring your code and your secrets stay safe. Okay, so our assembly line has built the software. It's passed all of our quality checks. It's been packaged up securely. Now, where do we put it? We need a place to store these finished goods before they get shipped out. For that, we need a secure warehouse. In the Google Cloud world, this is called Artifact Registry. It's just a single, managed, centralized place where you can store all of your finished software packages. These finished packages are often called artifacts, so Artifact Registry. It's the secure home for all of them. And what's really cool about this is that it's not a warehouse for just one type of product. It's a universal warehouse. It can store your Docker container images, sure, but it can also hold your Java packages, your JavaScript packages, even full-on operating system packages. It becomes the one and only trusted source for any piece of software you need to deploy.
So let's recap. We've built our blueprint with infrastructure as code. We've created our automated assembly line with CI/CD. We've got a secure warehouse for all our finished products. So what? Why did we go through all this trouble? What's the real payoff here?
Now this might sound a little weird, but the ultimate goal of all this incredible, exciting automation is to make deploying software boring. Yeah, boring. It should be a complete non-event. It should be so reliable and so predictable that it just happens in the background without anyone getting stressed out or having to cancel their Friday night plans.
So when you boil it all down, what do you really get? It comes down to these four things. You get speed, because automation lets you move way faster. You get safety, because all those automated tests catch problems before they ever reach your users. You get total auditability, a perfect trail from a line of code to production. And finally, you get rock-solid reliability, because the process is exactly the same every single time.
And I'll just leave you with this final thought. A really mature DevOps practice fundamentally changes how you innovate. It shrinks the gap between having a great idea and actually getting that idea into the hands of your customers. So the question is, for you, is that gap measured in minutes, or is it still measured in months of slow, risky, manual work?